information, and later as an intelligence specialist. He's a board member for Northwest Arkansas Space, a nonprofit working to build a science center with a planetarium, observatory, space exhibits, and hands-on labs. And their mission is to create a place for all ages to gather and explore science in Northwest Arkansas. I'm very excited about that because I just found out about it today when I was looking at this.
That was probably the most apt and accurate description. So yes, I am an engineer and I work in information cybersecurity, so I keep bad people out of Fortune 500 companies using computers in my fingertips. So my typical day looks like this. I call this the shrimp pose. Very poor posture. So I got the idea of this talk because of my visit to the Adler Planetarium, where I purchased this shirt. When I was a kid, Pluto was a planet. And that got me thinking, like, there's a reason why that Pluto is no longer considered a planet. Now, I know how much of that is a shock to you guys that Pluto is no longer a planet. Some people are exceptionally passionate with advocating for Pluto's planethood, but unfortunately science disagrees. As she said, I'm Dustin. What is a planet, though? Guesses, theories, ideas. There are no wrong guesses except all those that are. What makes a planet? How would you define a planet?
We talked about this. What are the three things that make a planet?
It's all right. Here, I'll look away.
How about size?
Size?
Size.
Size is a factor, right? Describe a planet for me? If you were like, teacher, hey, what's a planet? You would go,
It orbits a star.
sometimes, not always. What shape are they?
A circle.
Well, circle is two-dimensional. We're talking about space, and space is three-dimensional. At least as far as our monkey brains can understand. A sphere, yes, ma'am. If it was left up to the ancient Greeks, they said anything in the night sky that wasn't a star was a planet. So the Greeks, the ancient Greeks, decided that the sun was a planet, our moon was a planet, Venus and Mercury were planets. What's missing from that list, though? What's missing of that list of planets that the Greeks came up with? Earth, exactly. Earth was not a planet. Earth was just the origin. It was the center of the universe. To the Greeks, it absolutely was. And specifically, all of the Greek literature and all of the great astrological signs, they're all Greek or Roman in nature because that is the sky that they were looking at, was the northern hemisphere sky. So all of the everything we know about astrology came from the Greeks because of what they could see. If you go to the South Pole, if you go to the southern hemisphere below the equator, you would see a completely different set of stars. Your universe would look slightly different based on where you were at. But some of these have planet-like qualities, right? This one, Pluto, as the title of this, used to be a planet, but it's no longer. And there's reasons for that. Now, I put this as a misdirection because none of these are currently planets, though most of these were at some point either a planet or were classified or were going to be classified as planets before they're like, I don't care anymore. They threw their hands up and they said, forget about it. So this is the official, the IAU definition of what is a planet. You can go on NASA's website or the IAU and read this. It doesn't matter. But basically, there is rules to being planethoods. And specifically, there's things that exempt celestial bodies from being in planethood. So if it's a satellite that's orbiting something else, that's not the sun, it's blah, 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 blah. There's a whole bunch of different classifications, but generally, planets are round, they have a stable orbit. There's not anything that's gonna run into them on their standard trajectory. We're not gonna talk about meteorites or asteroids or comets or nothing like that. But yada, yada, yada. All of this doesn't really matter. But can we name the planets? Can someone give me a name of a planet?
Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune.
Correct. That's exactly right. We have the names of all of the currently classified planets. Now, there are two main classifications of planets. Does anyone know what the two classifications of planets in our solar system are? So let's think about this. We have all of those 8 planets, and they're fantastic and they're very different, but they're very different from each other, right? Let's think of a planet like Venus. Just like Earth, it rotates backwards, however. It's also very hot, it has lots of greenhouse gases, but is it a rock planet or is it a gas planet? What is Venus made out of? Rock or gas? Now remember, there are no wrong guesses except all those that are.
Yes.
Just take a guess.
I would guess that. Maybe rock.
Gas? Okay. So, no. And that's the great thing about guessing is you can be wrong. Because that's how a lot of science is operated. Is I think this is going to happen, and I want to test to prove that it happens. And the great thing about science is if you test it and you're proven wrong, you just learn something. So then you're like, so let's find out what it really is. Mercury, Venus, Earth, and Mars are what we call terrestrial planets. Planets made out of rock, physical, hard things. While the other 4 planets, we're talking about Jupiter, Saturn, Neptune, and Uranus, as gas giants. As far as we're aware, there is no solid center. It is gas all the way through. Okay? So those are 2, even though we both call both categories planets, there are vastly different things that can qualify what makes this planet versus what makes that other planet, right? Earth, every living thing that we know of in the universe so far is right here on this hunk of rock flying through space. But we share the almost exact same size and shape with Venus, which cannot support life as far as we're aware because it's so dang hot because of all of the greenhouse gases keeping all the heat in. Plus it's a lot closer to the sun. When we send a probe to Venus and it lands, I think the record is like 20 minutes before it melts and just the probe just disintegrates because of all of the acidic compounds, the heat, and all of those other things that make Venus a very inhospitable planet. Well, that's why all the life is here. But does anyone know where the most deadly place is in the universe that we know of? Most dangerous.
The black hole?
It's a good guess.
I vote black hole also.
Here. Because as far as we're aware, everything that has ever lived that we know of is here, and everything that has ever died that we know of is here. So technically, Earth is the most dangerous place in the entire universe that we're aware of. So maybe if we discover life somewhere else, then maybe we might be able to say, oh, that place, it's more dangerous or whatnot. So, talked about these things. And a total of 8 planets because that can always change. You will always see sensationalist titles in newspapers and such. Anything that has to do with science, you'll say, they found another cure for cancer. I'm like, wait a minute, I didn't know they had the first cure on lock, you know? But another one they like to throw out is, we found the 9th planet, you know? Pluto's, no longer, since Pluto's no longer the 9th planet, we found the 9th planet. And it's not like we found it. We've known about these things for a very, very long time. And it's just sensationalist headlines. Now, let's talk about the Former Planets Club, okay? So let's see. Like I said, in ancient Greek times, like I already said, the sun was a planet, the moon was a planet. And when Copernicus came around, we reclassified those things as different things, so that's why it has a very specific date. all of the moons of Jupiter were at one point considered planets. That was before we said, oh, if it orbits something else that's not a star, you're not a planet. Anyone know who discovered these? You know the name of the person who discovered Io, Europa, Ganymede, Castillo, also invented the first telescope, also found out very quickly why you don't look at telescopes into the sun. Anyone know? World famous explorer circumnavigated the globe? Castillo. I'm sorry. Oh my God, I just left one. Galileo invented the first telescope and also wanted to see what the sun looked like when you looked at it through a telescope, which is, if you don't know, let me tell you, never, ever point a telescope at the sun. Because what Galileo did is he looked up at the sun and it burned out one of his eyeballs. And then he was like, ow, that hurt. Thankfully, I have a spare. And looked with the other one, and Galileo, the world famous explorer and philosopher and mathematician and scientist, had only peripheral vision, can only see out to the sides because he looked through a telescope into the sun. Never do that. Even if there is one that has a solar filter on it, be very careful and understand what it is that you're looking at. Because has anyone ever heard the expression burning ants on the sidewalk with a magnifying glass? Yeah, you can do that to your eyeball because telescopes are basically light focusers. It takes this much light and focus this amount of light into a very, very small point. However big the telescope is, that's how big it's making your eye. So if the telescope you're looking at is this big around, imagine if your eye was suddenly that big around. That's how much light is hitting your eyeball in one small point. Okay, so just we'll touch on these here in just a moment, but this one I just found out about. I didn't know about Chiron, which is, if I remember, Greek. Greek mythology was one of the boatmen of the river Styx, if I remember correctly. I don't remember. I don't remember exactly because I just learned about this one here, and it's classified now as a centaur, and I have no idea what that means. So don't ask. I don't know. I don't know everything. And then Pluto is the one this talk's based around. We discovered it in 1930, but we knew that it was there for a long, long time because we can tell that there was something out there that was massive because of its tug on Neptune. Its gravitational pull had an effect on its other planets, so we could determine that Pluto was actually there long before we actually spotted it with a telescope. But if you notice these all dates here, that's Pluto's demotion day, it's 2006. And Chiron and Eris, we'll go over that in just a second. So this is a mock-up of our solar system. This is both not to scale in how far away the planets are, and this is also not to scale how big the planets are. At this size, for Jupiter to be this big, the sun would have to be almost as big as this room in terms of height, and Jupiter would probably be in those trees over there. So our solar system is massive, and these planets are massive, and at Jupiter at this size, Earth would be about the size of the moon here in this picture, which would not make a very good picture, but this gets you an idea. And also, the solar system is three-dimensional, and so most of the planets could be anywhere over on this chart here. But these are our four terrestrial planets and our little moon. But let's talk about Ceres. Ceres is one of the first planetoids or dwarf planets that we decided was a planet. And then for a little bit, Ceres was a planet in our solar system that they broke down in textbooks. And we and children had to learn all the planets of the solar system, including Ceres. But we found another one, and then another planet just about that size, and another planet, and it made us have to reclassify what planets were because we found so many things in this zone in between Mars and Jupiter, and we reclassified all of those as asteroid belt objects. And then a similar thing happened with Pluto, and this is Pluto and its moon. Pluto and its moon are almost the same size. So for a while they called it a binary planet system, which is kind of weird. But then they found Eris and Make, and a whole bunch of other stuff out there. And the more stuff that we found, the more it didn't make sense to call something as small and as distant as Pluto a planet. So in 2006, they officially reclassified Pluto as a dwarf planet or planetoid, or just a regular old celestial object in the solar system. But as you can see, science gets it wrong sometimes. And we humans like to classify things differently sometimes. So as we learn more, we change. Now, again, I ask, how many planets are there?
8.
8? No. Because exoplanets. Does anyone know what an exoplanet is? Oh, you thought we were just talking about planets in our own solar system? No, man, we're going to the stars. What is an exoplanet?
Outside of our solar system?
Exactly. And how do we find planets outside of our solar system? How do we even know they're there? We can guess that they're there, but how do we find out and prove that a planet is orbiting a distant star? Does anyone have a guess? Go ahead.
We use a rocket, or is our rocket?
If we launched a rocket to the closest star to us, and if it traveled at the speed of light, which is way faster than we can travel now, we can barely get a quarter of the speed of light, and that's if we used like nuclear bombs and a bunch of other stuff to propel something super fast. If we could get to the speed of light, which is about 4 times faster than we can go now, it would still take 4.2 years just to get there, to travel. And then it would have to, because if the rocket just being there doesn't tell us anything, because we have to get that information back. So then it would have to turn around and then fly back. Well, also it'd have to stop, so to slow down so it doesn't blow past our closest star, Alpha Centauri. It would have to slow down, which would greatly increase the time it would get there. So it would not be, if we actually launched a rocket with the intention of going there and pulling the information back, it wouldn't be for several hundred generations of humans with our current technology. So then we have to use a different method. Here's some notable exoplanets. The Proxima Centauri b, which is our closest star, and this planet is 1.27 times the mass of Earth, so about Earth size, and it's also in the habitable zone, but it orbits a red dwarf, which means that it's a much smaller and colder star. Our sun is fairly young and hot, and like, think about, 20-something-year-olds, they're all hot and bothered, they're all energetic. Well, dwarf stars are at the end stages of their lives, so they're a lot less energetic, right? But they're also smaller. But it orbits its star every 11 Earth days, so it's moving fast. But because the dwarf stars are not very big, that's a lot less distance to travel. It's not like it's traveling much faster than Earth, but because the star is smaller, the orbit is smaller, and thus the habitable zone that it's in is smaller. And habitable zone means liquid water can exist. It's not too hot that the water evaporates, and it's not too cold that the water freezes. And then you've got, this is the newest one that's really been on people's radar, it's K2-18b, which is 124 light years away. So if we could travel at the speed of light, it would take us 124 years just to get there one way. And that's if we could stop instantaneously too. And it's called a super Earth, which means that it's very, very big. It's not super Earth because it's like amazing, it's a super Earth because it's much bigger. This one is about 9 times the mass of Earth. So imagine if you were just transported to K2-18b, you would be 9 times heavier just walking around. So I don't know how much you got. How much do you weigh, Leland?
Can you ask someone else if it's embarrassing?
It's not embarrassing. How much do you weigh, Evan?
Where did
Usually 105 pounds.
105 pounds. So you would weigh 900 pounds, roughly. So you wouldn't be able to walk, essentially. But we don't know, and this is what's really cool, is that the James Webb Space Telescope, JWST, we'll see a picture of an image that the James Webb Space Telescope has captured, has detected methane and carbon dioxide, which is huge, which as far as we're aware, the only means of producing methane and carbon dioxide is by biological means. So either we have detected a way of that there is somewhere in the universe that can make methane and carbon dioxide together that is different than anything else we know before, or there might be life on this rock around another red dwarf out there. So that's fairly interesting. That is this right here is the most concrete possible proof that there is life outside of Earth. So, really cool. And here's one way that we can detect that all of these things and we know what it's there is because light. Light leaves its star, and we can measure the light of the star and the light as the planet passes in front between us and the star. We can detect that, and we can measure based on wavelengths of what molecules make up its atmosphere. So that's pretty cool. We can also do this to stars, so we can tell that a certain star is a dwarf, or we can tell a certain star is made out of this, or a certain star is made out of that. We can tell all of these different things. Now, here's a super cool part. This is a size comparison. This is K12b. It's not as big as it is more massive, so it's a lot more dense than Earth. But it's big, but still it dwarfs in comparison to the size of Jupiter. But Jupiter is a big boy. This is a picture from the James Webb Space Telescope. Back in the Hubble days, they picked out a random patch of sky that to the human eye was just black. And they just took a picture. And it took a long time because in order to capture this much light, it takes a little time. But this is what you would consider a blank patch of sky in the night sky, completely featureless. But when you take the James Webb Space Telescope, you get an image like this. Now these points that you can see are 6-pointed things. Those are stars. There's probably like maybe a dozen in this picture, which is stars inside of our Milky Way galaxy. These are our neighbors. But everything else in this image is a completely different galaxy with hundreds of trillions of stars each. And of those, how many countless of those stars have planets around them? So the answer is, how many planets are there? Countless. There are less grains of sand on all the beaches of all the Earth, and all of the planets that we know of that have sand. There's less sand on those than there are stars, just stars, in this picture. That right there is an entire galaxy where untold, countless billions and trillions of stars exist and untold planets. Who knows? Space is big. Now, when I talked about how we actually detected exoplanets, this is the Brashear telescope that was at Swarthmore College outside of Philadelphia. Also, if you ever watched the movie Addicted to Love with Matthew Broderick and Meg Ryan, this telescope was in that movie, and he used it to look across the campus at his girlfriend, which is not how telescopes work. But it's just really cool that this telescope's in the movie. This is the first telescope that has documented of attempting to detect an exoplanet, a planet outside of our solar system. They ultimately failed, but we later detected that the efforts by this telescope were actually correct, that there was a planet around the star that they were attempting to prove. Again, the planet passes in between the star and you detect that measurement of difference of light, because we look at a star for a long time, and then we notice periodic small, tiny little dips in the amount of light that reaches us. We can make a guess that there's something that periodically comes in between us. So we can make a fairly good guess that it might be a planet. First telescope. Where is that telescope now? Because I said it was at Swarthmore College. It's here in Northwest Arkansas. This telescope is here. That's my goofy looking self. There I am. This is members of NWA Space, and this is us unloading the feet. This part that's underneath this floor. These feet weigh 2,000 pounds and are made out of cast iron, okay? There's a telescope tube that I literally pushed over here, it was on dollies, and I threw my back out. This telescope is here in a boat storage in Northwest Arkansas, and we're building a science center and an observatory around it. This historic telescope right here. This telescope was built in 1909, which makes it over 100 years old. But historic and local now. So now we're going to get to the point of questions. But here is a QR code in case that you want to know more about the Science Center or any of that other good stuff. This takes you to our website. But let me see how good I am on time. Okay, good. We'll have plenty of time for questions. There also on there is a letter of support that if you also believe that Northwest Arkansas deserves a Science Center, then we have a letter of support on our website which will help show the large donors that not only is a Science Center wanted, but is also able to be sustainable here in Northwest Arkansas. Because that's the phase that we're at. We've got the telescope, we've got the program necessary, we've got the qualified people, we've got the architectural drawings. We have everything except for the $100 million that it takes to build a world-class science facility. So, and we're not, unless you guys have $100 billion in your back pocket. I actually asked that question and later found out that it was Lynn Walton that I was talking to. So I will ask that question to everybody. If you happen to have $100 million you wanted to donate, sure, we'll take it. But in all seriousness, how we get these science centers funded is by showing metrics and need locally. So the letter of support is one way to do that. But questions? Yes.
I read once that a Google number is like 100 digits or 101.
1 to the 100, yes.
A Google Plex is like 10 to the 10th of
10 to the
100.
100th to the 100th.
Yeah.
Yeah.
How, I read after that the amount of books it would need to write it down would be enough to overflow to the universe.
So, here's another way to look at it. Yes, if you counted to a Google, you would be long past the heat death of the universe. All the stars in our galaxy, that in our known universe, would burn out long before you got to the end. Imagine this: you have a gear, a 1-to-1 ratio gear. So you turn this gear one time, and when it turns one time, it moves the other one 10%. Okay, and then by that second gear, by the time it rotates all the way around, the next one will have moved 10%. If you had that to 1 to the power Google, you could turn for the entire length of the universe that we know of, and you wouldn't even be halfway. Google is a very, very, very big number. Any science-related questions? Anything at all? I don't know a lot, but I know a little bit about a lot of things. You have no questions? I find that hard.
I have no questions, and I made it.
So, if y'all don't have any questions, I do have one more thing that I want to show you guys. Let's see, I don't know if we'll be able to hear this. So, this, oh, hold on.
That's here. That's home. That's us.
Let's take a little bit of this is an image called the pale blue dot. Back when Voyager 1 and 2 were about to start leaving our solar system, Carl Sagan and the scientists working on the Voyager project decided, before it gets too far away, why don't we have Voyager, and I believe this was Voyager 1 that took this picture. Let's have Voyager 1 turn around and point its camera home and just take a picture. And this is that picture. And here, that little speck, this is a sunbeam from the light hitting the Voyager camera. But this right here, this speck is Earth. And this is Carl Sagan's words about this picture and its perspective that he said way back in, I believe, 1978-ish? I forget exactly. I apologize. This is about 3 minutes long.
That's here. That's home. That's us. Brilliant. every human being who ever was lived out their lives. The aggregate of our joy and suffering. Thousands of confident religions, ideologies, and economic doctrines. Every hunter and forager, every hero and coward, every creator and destroyer of civilization. Every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, in a mote of dust, suspended in a sunbeam. The earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and triumph they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes. Settle? Not yet. Like it or not, for the moment, the earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known.
So for all of the different things that I've talked about, all of these planets that we discussed, like I said, everything that we've ever known of that is based on life is here in just this little tiny speck of nothingness in outer space. Thanks, everybody. So I had budgeted a lot more time for questions. We've got about 20 minutes left, but I'm available to answer any questions. Yes, ma'am.
Is that telescope really made here, or you bring it?
We brought it here.
Or brought it
So
from
the
where?
telescope lens was, I believe, initially crafted in 1907 by the Brashear Optics Company, and just the end of the telescope, the lens, weighs over 200 pounds of glass, and as described by our insurance adjusters, as irreplaceable, perfect. It is 200 pounds of glass hewn to the exact specifications, so when you put it on that exact telescope and look through the end of that telescope, you see celestial objects like they were right up your face.
Wow.
So, yes, but that is the telescope that is now here in Northwest Arkansas.
It is the really very, very first telescope in all human history, or in what sense?
That was the first telescope. Now, Galileo invented the first telescope back in his day, which was 1600s, I forget. That is the first telescope used to try to prove there was exoplanets. So we assumed that because our star has planets around it. We assumed other stars did too, but we had no way to prove that. Our telescopes aren't big enough and great enough that if you look through with a human eye, that you could guess that there was a planet. Planets are too far away, they're too dim, and the light takes far too long for us to reach. So we devised a method of trying to test for exoplanets, and that telescope that's here in Northwest Arkansas was the first attempt to do that, which they failed, but that star did have a planet on it that they later proved. So they were moderately successful. So,
Thank you.
but yes.
Yeah, so proud of.
Oh yeah.
Thank you.
I think it's really cool.
Can we visit your science lab?
Not yet, because we currently that telescope's in a boat storage in several pieces. However, the quick story is that the planetarium that had that telescope the planetarium that had this telescope, Swarthmore College, they wanted to repurpose this building. And if you haven't noticed, it doesn't seem like it's been used in a while. The last time it was probably made to look nice, it was for the movie that had Matthew Broderick in it. This paint was from the 1985 was one of the last times they really painted this thing. So if you can't tell, this building was not in great use because this is not a research grade telescope. It doesn't have any of the normal go-tos. It has no modern conveniences. The electronics were redone in the 70s. It looks like an old missile silo, like it's got clocks and stuff in it. And you could kind of steer it where you needed to, but to look through it, you'd have to get on this ladder that had a pulley and a seat that you would lift yourself up to the right height, because this could be 40 feet off the ground. So this is an old school telescope. And obviously this has not been in use for quite some time because they were not using it to attract students. It was research from 60 years ago, not current day. So to take the money to restore it to be a research grade telescope was worth more than they were willing to spend. So they put a call out. Who wants this telescope? Ideally you could put it in a museum, but ideally we'd like it to be restored to be used to attract people into STEM, science, technology, engineering, math. And we put in our bid and they said yes, and they liked our idea so much that they even paid to have it shipped here. So that was about $7,800 just to move it, and they had to take cranes. If you go on our website or on our Facebook page, there's a walkthrough of them taking this apart. But even still, it hadn't been touched in basically 20 years. You could still take the tip of your finger and move the telescope, but barely touching the end of it. So it's still a fully functional telescope. Yes?
I wasn't.
Oh, I thought you raised your hand. Yes, ma'am.
So where's the whole space?
This is my daughter, Ari. One of the reasons why I was running in here at the last minute. Thankfully, I had everything ready to go, so I could just plug and play. But yeah, we're building a science center, and in order to do that, it takes people like you. If you're interested in knowing more or volunteering or knowing more about our story or anything like that, it's there. And Facebook, Instagram, TikTok, I think. I don't know, I'm not the social media guy, if you can't tell. I'm a little too old for that. But all of our information is there, and we're thriving, and we're always looking for more volunteers. One of the things that we do the most often is we do First Friday up at the Bentonville Square. We tried to do a similar thing at the farmers market here in Fayetteville, but they're very restrictive on the types of who can just go. And since we weren't a local artisan or making goods and we weren't selling anything, we were more of an informational booth. That's not really what they wanted at the farmers market. So we will not be coming to Fayetteville's farmers market, but we do star parties, we do birthday parties, we do science outings, we do library talks like this. I have another talk about cybersecurity that I'm going to be doing for the Osler Lifelong Learning Institute, OLLI, which is for more retired folk. I've got that later this month talking about cybersecurity and information security matters and stuff like that. So if y'all have, and we do this all for as low or zero cost. If it's like a birthday or a corporate event, we ask for a donation so we can help keep the lights on and making sure we get the science center built. But if it's for like, hey, set up some telescopes, we'll take a look at it at a school, we just did that a couple weeks ago. We set up telescopes and let people look at Jupiter and Mars, and several other planets that happened to be up at the time. So it was a good time. So that's my time. Thank you very much.
Thank you. It's so important. It's a pity not many people show up. Because of the weather, it's so good they were out.
Oh, yeah.
Nobody's
Yeah.
doing anything.
But it's
Nobody's
so
doing anything
wonderful,
indoors.
wonderful topic.